Okay, so back to this board. Let's figure out what's going on here. Now this is the 15 volt supply. They come in here, and these are the two tantalums I've already replaced. Now this one here, that one was originally blown. That may be a clue. Let's try and figure out what's going on here. So I've got my meter here set up into continuity mode, so it's going to beep if it's a short. Let's check across this one. That is showing as a short. Okay. Just check across the other one. That one is looking okay. Let's go between these two. That's showing as a short because they're in series together. So this tantalum here, which is brand new, is giving me a short circuit. That's interesting. I've taken the tantalum out. Let's check it again. It's a short. What are the odds of that? That's kind of unusual. Getting a brand new blown one. Oh well. Get another one. Next new one. Let's just test it. Just see. No short. Let's put this one in. And we'll try it again. Nice shape I'm doing. So positive that way. Shove that through. Unusual to get a brand new bad one. I've never had that before. Anyway, we'll solder this in. And this might resolve that problem. I think I might have lost the pad when I pulled the other one out. The pad's not there anymore. Once I get soldered through to the other side, just make sure we get some in there. The pad on this side had no connection anyway, so it's fallen off. So unfortunately I don't like that sort of thing happening. But unfortunately it does happen from time to time. Let's give this a clean and then we'll try it again. Let's recheck for a short, just in case something weird's happening. Cut around. Doesn't matter, it's fine. And fine, no issues there. Let's put the board back in and try again. Okay, the card's back in, meter is still hooked up, so let's power it up and see what happens this time. We have 15 volts. And we have one display. No error messages. Well, this looks promising. These are lighting up. These neons. The LED there is on. This one is not on. Don't know what the significance of that is. Let's see if we can get anything out of it. Ohms. Hey, switching on. Voltage. AC and DC voltage appear to be there. Excellent. We've got some progress. I'm going to disconnect this meter and we'll carry on. Right, as you can see I've relocated back to my desk now, which is where I really should be when I'm working on something like this. But obviously I had to do repairs on the cards and bits and pieces, and it's just too much hassle trying to pick this thing up and put it down again. It weighs 35 kilos and barely pick the thing up. Back on the bench now, we seem to have that power supply sorted out. We can do some proper testing. I've got the meter hooked up in voltage on the output of the unit. So that's going to measure the output voltages, anything else I can output from this thing. What I want to do here is go through the various controls, various functions, and see what we get on the meter. See if it's all working now. Let's try it. So I've got my Variax set up on here, 230 odd volts coming out, so monitor over here what the power is. Currently using nothing, which is what it's supposed to be. Just turn the power off, switch on. 146 watts and settling down, it's getting lower. Obviously as the capacitors and stuff charge up, so 138 watts, that's alright. Power factor of 0.8, it's not too bad. So let's see what we're doing here. So we're on DC volts right now, output is currently turned off. Let's turn the output on, positive. 0 volts, we are getting an offset. So let's put some voltage on this, 0.1 volts, getting 0.2. Okay, getting 0.3, got an offset, alright. 0.4, but it is outputting something. 1 volt, 1.1. 1.2, it is kind of working. So let's go up to 10 volt range. Now we're getting 13 volts and that's what we're getting. That's good. Now I can go up by ones. Up to 19, that's the maximum, and we're doing 19. Great. So let's go down to 4, just for the sake of it. Actually, let's go down to 2. We're getting 3. 1, we're getting 2. So now we have a 1 volt offset. Isn't that curious? So there might be some digital control problems going on there. Go down to 1 volt range. we're getting 2. Okay, so it's out by a factor of 1 there. So if I do 100 millivolts, or 10 millivolt range, we're doing 10 millivolts, we're getting 20. So there's definitely a offset going on there. So let's do 100 volts. Doing 10 volts there. We're getting 2 volts. So that's not right. We should be getting 10. Actually, in fact, we're getting minus 2 volts. See that? Back to the 10 volt range. We're getting 2 volts. So if I go up, we will get 10 volts on this range. Up to 19 until it says out of range, but that's okay. 19, that's it. So let's go back down to 1 volt. That's there. 1.9. Yep. 100 millivolts. That's there. 19 millivolts. That's out by 10. So this is interesting. 1 millivolt. It's out of range. I need a bit of meter for that. So okay. Back to 10 volt range. Turn it down to 9 volts to 100 volt range. There's no errors. I'm getting minus 2 volts. So something's definitely very wrong there. So the high voltage range isn't working. Okay, let's try the 1000 volt range. That also is not working. Oh, range is off. Error, oh well. What's that not liking? Turn it back on. Okay, it's not liking something. Won't let me turn it on. Let's try negative voltage. No. So something's definitely wrong with the 100 volt and 1000 volt ranges. So okay, we've still got things to sort out. That's alright. But below that is kind of working, but we've got that weird offset on there as well. So right, that's DC volts. Let's try AC volts. So let's change to AC. So I've got 0 volts, 1 kilohertz AC. Let's change to 500k. 100 millivolts. Let's do 1 volt range. And let's go up by 0.1. We've got nothing there. So AC has got no output. Oh, I should turn it on first, shouldn't I? Turn the output on. Got 500 millivolts at 500 hertz. Give 1.27 volts. That's very different. 1 volt, I'm getting 1.75. 10 volts, getting 17. Same ratio error. If I change this frequency, does that change it much? No. Let's just change ranges. That beep's kind of disconcerting. 10 kilohertz. 1 kilohertz again. Yeah, so the frequency isn't related really to the voltage offset here. So let's go up a bit more if I can. Probably only going up to 19 on this range. And I'm getting 29, it's out by 10. At 9 I'm getting 16. So at the 1 I'm getting 9. So there's definitely something going on there. Let's try 100 volts. Fail 5. We've got an error message, that's something. Can I turn it back on? No. Reset. Fail 7. Fail 5 and fail 7. Can I turn it on? I can at 0 volts. It stopped me from using a high voltage range. That's on, but there's not much going on. So 100 volt range, it's got an output. Oh, it's gone to DC. Output on. We're getting 9 volts that one, which is the error we knew about. Fail 5 again. Okay. Try and turn it back on. Won't let me. Do the reset and I get the fail 7. So those high voltage ones still aren't working, which is the original fault I saw when I first tried this thing out. Let's try resistance. So in resistance mode, output is now turned on. I've got it set below 10 meg, and I'm getting 10 meg. 1 meg, I'm getting 1 meg. 100k, getting that. 10k, getting that. 1k, yep. 100 ohms, yep. And 10 ohms, yep. Okay. This also does 100 meg, but this meter doesn't do that. It's out of range. Can't go that high. So it looks like the resistance is working okay. So the resistance is good. Low voltage are kind of working on DC. AC's got a serious error. Currents, I don't know yet. Let's actually do a self-test, shall we? See what happens. Self-test is running. Got a sticker over there, you can't really see. It says running. Fail 2, okay. So you have fail 2. That's it, I think. Testing display. Testing all the indicators, obviously. I don't know what this is doing. I should just wait for a minute, see what happens. I think that's just sitting there. Do another one. Done. Okay. So we got error 2 on the self-test. We also see error 5 and 7 when we're trying to use the unit. Requires some more investigation. There's a couple of capacitors down here on the board which I just replaced. This is obviously the bottom view. I've taken all the panels off the bottom here. There's 2 caps there. I replaced those just now. They're 330 microfarad caps. They measured 280. Resistance looked kind of okay though, 0.1 ohms. The ones I had available were 470s and I put those in. So it's got a bit of extra capacitance on that power rail there, whatever those happen to be. I don't actually know, I haven't looked at that. There's also some big caps right here. I haven't tested those yet, but I think I'm going to need to test those because they're big caps and there's a good chance they're really important. It may be part of the problem is too much ripple going through that particular supply, who knows. So I need to look at those ones and just be sure they're okay. But generally the caps I've been getting, I haven't really found anything too bad. They've been pretty good. I'm quite surprised. Yeah, I mean, it's nothing been horrendous. It's nothing been completely dead, I don't think. I think it might have been one cap I think I found. So that little piece of clip I found earlier on as well, I don't know if I recorded in this video, it might have just been a live stream. There's a little piece of clip, and that's because it's got these little clips that hold this bottom section. And it's got screws and these clips as well to help stabilise it. So yeah, obviously that's what's causing that particular piece I found. So I've got replacement ones for these, but they all seem to be tight, so I'm just going to leave them alone. I don't know which one it was that broke. They all seem to be holding okay, so I'm just going to leave it. Don't think I need to change anything there. What I've also done is I pulled out the power amplifiers, which normally go in this section here. Pulled them out from the top. I'll show you those in a second. They've got some capacitors on there, which I'm going to need to change. Some tantalums on there, and there's a couple of big electrolytics that they think changing too. So those are done, and I can test all the actual transistors to make sure the transistors look okay as well. So I'm going to do that now. So there are 3 power amplifier modules here. This one's got a couple of electrolytics on it, and there's a couple of tantalums floating around as well. This one's a bit simpler, just a couple of tantalums on it. And this one is even simpler again. Not much on that one. But on the back, all the big pass transistors. So I need to test all those to make sure they're all looking okay. They all are original. They're all original date codes. So I don't think anything's been replaced, although there are differences in the parts. I'm not quite sure whether it's original or not. I guess it is. But they all got the right date codes. You know, don't look like they've been changed. These have got markings on them for the, I'm guessing, the gain on them. So it says 430, that one there, 430, 440, 440. And these ones here have got 350, 350, 410, 410. So I'm guessing those are the gains. I mean, I really don't know, but the date codes look like they're right. So I don't think anything's been replaced. I think these are all original, which is great. And hopefully they're all okay. So I'm going to do some just basic testing with the multimeter and just see if I can get diode junctions and that sort of stuff. And just make sure they look basically right. I'm not going to check for gains or anything. I'm just going to just make sure there's no blown junctions. But the boards themselves look fine. I can't see any faults on them anyway. I've had a quick glance over. There's no signs of any burnt resistors or anything like that. I haven't noticed anything at least. A couple of ICs on this one. And this one over here's got one as well. So I'll just reseat those ICs. Make sure they're nice and clean connections in case they're a bit dodgy, because I do need resetting from time to time. The tantalums I'm not too worried about, so my history with tantalums is not that bad, alright? Generally tantalums I leave them alone unless I've got a reason to suspect they've been blown or been stressed. Now the thing is, the Datrons, as I said before in a very early part of the video, or the previous video maybe, I'm not sure how I've structured this content because I've got so much footage. They are underrated for the voltages. They're usually recommended like 2 to 3 times the voltage rating versus the supply you're actually running the tantalum on, just to give them a big margin of error to allow for any ripple and stuff like that, so they don't balk at it, you know, they don't like it. In here, some of these tantalums I've been finding are less than 2 times, and it could be why there's a tendency for them to fail. Like I've got 25 volt tantalums on a 15 volt rail, which is a bit borderline somewhat, so you really want to be 30 volts, 35 volts on those particular rails. I'm nervous about tantalums, so I think I'll just change the ones on these boards, make sure these are all refurbished and back in the unit. And once I'm comfortable these are okay, at least I can then ignore these and concentrate on the main cards that are inside the unit. Let's just go around and check every dial. Start here. That's fine. Fine. I do like the fact that this thing beeps. It means I can do it without looking at the meter. Because I'm really looking for is a short and open. And if it beeps, I know I've got a diode junction which sounds about right. So it means I don't have to look at it, which is great. Okay, here we go. So that's all those diodes. Checked on that one. Let's check the diodes. And this one's going to do the diodes in one go, and then I'll come back to the transistors in one go. That way I know where I'm up to. See how much faster this is by having it beeping? I don't have to keep looking away. It's brilliant. Love it. And this one here. Great. So that's looking like the diodes themselves are good, which is always a good sign, because sometimes if you get a big failure or something, the diodes will fail. They'll short out or blow open or something like that. So that's looking promising straight away. Let's start with this board. There's a lot on it, but let's just do this one. Right, so let's now test the transistors. So we go into these screw holes. One is screwed, because that's the mountings. Let's go into the terminals. That's fine. That's fine. Let's do the same ones over here. It's okay. There could be a slight imbalance, I'm not too worried about that. Come on, get on there. That's different. There could be my connections. I might be using the wrong junctions. Let's try. There we go. Now we've got 610 there, 510 there. So we're getting something. I'm not sure about the pinouts of these transistors. You see, I've got to try and figure that out. No, they're different. 680, 680 there. 510 there. So there are dial junctions. Don't forget the circuitry around them is going to be affecting the readings as well, so I'm not 100% set on getting perfectly balanced readings, so it probably won't be. There we go, 480 there, 680 there. So we're getting dial junctions across all of those. That seems basically okay. I could, if I really wanted to be fussy, I could go around and test all the resistors as well and see if they make sense. Unless I've got some other kind of fault, there's probably no point in testing resistors because they don't tend to fail generally unless they've been overloaded by something. I don't see a reason to suspect any of them being bad. This particular type, this newer, more modern style. But we got these older carbon composite type here as well, boxy style ones. Those are more suspicious of. They can fail, so those ones I'll definitely consider checking. Let's check this one. I'm not sure what the pinouts are on this one again, as I said. That one there, it looks like. Yeah, this one. 470. 704, so these two are at least matching each other. Get the probe on there. 702, that matches as well. That matches as well, so those transistors in that one are probably fine too. There's nothing there saying they're open anyway, so that's always good. 700, 460, 460, 700. Very slightly lower, but again that's probably because the circuitry's around it. So none of those transistors look like they're blown, which is good. That's a good thing. That's a bit of a relief. So these are probably all fine, but I do need to look at these capacitors. I really think they need doing. There's also a transistor over here. It's a BC184. I'll just check that one. Yeah, that seems alright. Some probably diodes or something here. Not sure exactly what these are, two legs. They're giving a junction one way, nothing the other, which is fine. So that's probably fine as well. So I can't already check that one. Oh, there's one over here I missed. Yeah, that's low, but okay, it matches this one. Both about the same. So I think that's all fine. It's got an anode cathode, so yeah, it must be diodes of some kind. Probably Shockeys or something like that. And there's another transistor down here I need to check as well. I think, was that a diode? No, it's another diode. There we go. Right, so that looks alright. This has got some transistors on here. Let's check these. Well, that's interesting. That could be a concern. Diode junction that way, short the other way. Or are those linked together? I can't tell. I have to look into that one. Sometimes I link them together because they're using a diode junction. That's got 604, of course, that one. the same part, is it? BC214, that one is. So that's an interesting one. That one might be bad. We should have to check that. Do some more here. It's okay. It's BC184. It's alright. Some more diodes here. That's the transistor. We'll check that one. It's alright. We've got a diode there. Yep, okay. So we've got one part which I'm suspicious about because it gave a short. So depends on how they got it set up. Sometimes they just use a single pin as a diode junction. Sometimes they do that. But to see that, I'm going to need to look at the circuit diagrams and figure out what's going on there. So I need to look this one up. So I shall come back once I've done that. Right, so according to the circuit diagrams, that is Q5 just here, and that has got a 0.47 ohm resistor between two pins, which could be why we're getting this reading. So let's just do a resistance measurement instead between these two and see what we get. 0.5 ohms, so that's fine. That's actually from that resistor, so there's nothing wrong there. Excellent. So I'm going to refurbish caps in this thing so I can put these things back. I'm not going to record that. I'm sure you don't need to see me doing that part. So now we're replacing these capacitors in here, these electrolytics. So what I'm just doing is I'm getting the capacitors. I've already taken the original ones out. Haven't even tested them yet. I might do, just out of curiosity. And now I'm just getting these other ones, and I'm just trimming the leads so they don't protrude too much on the back of the board, because these you can solder them from the top. So I've desoldered them, and I'm going to solder them from the top as well. You just have to make sure the leads don't protrude too much and potentially short out at the bottom. But you just trim them back. You just keep trimming them until they're all gone. So you get the height you need. Meaning sort of estimate, anyway, I'll be looking at how much they protrude from the face when the capacitor sits down. Look down the gap and check they don't stick out too much. See through there? They're just about perfect. So now I can solder these down from the top, the solder will flow through to the bottom, and that'll be fine. I won't have to take the board out. Technically I should take the board out to do the tantalums. Yeah. There's only a couple here, I can do this from the top as well. It's not a big deal. So you go and just testing this capacitor now, and we're getting 15 ohms, 42 microfarad. So 15 ohms is somewhat high. Let's see what this one's like. 52 ohms, 24 microfarad. Yep, so those caps are definitely bad. They needed doing, no doubt. So I'm just revisiting the power supplies just to be absolutely sure I'd missed something here, because I didn't check every single supply. So what I've done is some preparation to note down what voltage should be getting which points on the bottom here. So we've got the cards over here, the bottom of the cards, the connectors, and I've traced these wires to the various points that come over here and over here and up here. I've noted down which post is for which voltage, and the 0 volt comments and stuff like that. You can't probably see it on camera too well. Normally there's a shield plate over there, so I've taken all that off obviously. And this is just an easy way of doing it, because what I was doing before was actually hooking up onto the card, onto the test points, dropping the card back in again, unplugging everything, and you know, it's a bit of a pain. I thought I'd hook up to this side. The only one we can't actually measure on this side of the board is the plus and minus 20 volt rails. The 0 volt common for that is over here, but the actual 22 volts come down via a cable down to the actual module stand here. So let's just do some tests and we'll see how we go. Let's power it up. Now I've got to be really careful where I leave my hands. In fact I can't leave my hands anywhere because there are high voltages around the place, so I have to be really careful what I'm doing here. So I can rest on the chassis obviously, but that's about it. So I'm going to stick that probe on that one, which is a 0 volt common. So obviously watch the meter for what we're getting. So we've got this one here which is supposed to be minus 15. There we go, that's fine. This one's supposed to be plus 15. Yep. This one's supposed to be minus 8. It is. It's supposed to be plus 8, but this is unregulated, I think. It's plus 8, there we go. And there's minus 10. That's okay. So those voltages there check out alright. Let's come down to these ones. Plus 8, that is an unregulated, oops, get back on there. Unregulated 8 volt supply, so it's 10 volts. It's basically a rectified AC input. That's all it is, there's no regulation, that's why it's over voltage. Plus 5, yeah, it's getting almost 5.2 there. And over here we've got some sensing, 0 volt sensing and stuff over here. There's a 5 volt sensing line here which is feeding back. There's the 5 volt rail there, 5.1. Minus 175. That's fine. So all those check out. So you've got some up here. Let's see what these do. So that one there is supposed to be 0. Minus 15, okay. Supposed to be plus 36. And do that slipping off. Let's go to here. You know, 35.5, that's alright. And the other one's plus 15. Yeah, 14.7 is a little bit low though. Yeah, I don't know, there might be a bit off. 300 down? Maybe something to look at. So that 15 volt rail, it's only a small offset, but being as those 15 volt rails are used to provide things like op amps and stuff like that, they could potentially be a problem. I mean, the 36 volt rail is half down by half a volt, and that's probably okay. It's not such a critical rail, but usually 15 volt rails are usually fairly critical. Now that's actually coming from a 7815 linear regulator, which is attached to a heatsink on the power supply. So I could actually swap that out for a new one and get that voltage up. I could easily do that. It's actually very tempting to do that, to try and bring that voltage up, just to tweak it slightly. It looks like it's just a little bit weak, but then it may not actually matter. It may not be critical. If it was critical, I would have thought they'd have adjustments in here to allow you to tweak those voltages. But normally the case with those precision power supplies, you'd have a way of adjusting them. Like on the 0 volt reference pin of the regulator, you can actually tweak that voltage on that pin and adjust the regulator output, because that's just what it's using as a reference point. It assumes 0 volts, but if you stick a diode in there, your voltage will come up by diode drop level. There are ways of doing adjustable voltages with a fixed regulator like that. So I think the fact they haven't actually put an adjustment in means it probably isn't that important, but I can't find any specs, at least I haven't found anything so far, that tells me what the specifications are for the accuracy of the voltages. Now usually there'll be a list of saying this voltage must be this within 0.1 volt or whatever. Usually I'll say something like that. I haven't found the list of that yet in the manual. I expect it's in there somewhere, I just haven't found it. If I can find it, at least that'll tell me whether it's critical level or not. I'm going to keep looking for that and see if I can find it. That's just something to keep in mind, that 15 volt rail might be a little bit weak. And like the 5 volt rail is sitting at like 5.1, 5.2, which is slightly on the high side. May not matter, it's pushing it a little bit, I think. Once you get voltage drop across the connectors and onto the balls themselves, and they've got usually the balls got their own regulated supplies on the balls as well sometimes. They go through filtering and get a bit of drop through those as well, so it probably doesn't matter too much. The 15 volt one is I'm mainly worried about. But at least all the rails are there, there's nothing missing, so at least I've confirmed that bit now. Yeah, I should have done this one in the first place, it would have saved me a lot of time. Ripple wise, they should be fine. I mean, I've already recapped them all, so there shouldn't be any issue with the ripple, so I haven't checked that. I don't think it's going to be a problem. Now there's another supply here which I need to mention, which is over here. It's a 38 volt supply. The card which plugs into the bottom of the board, and this is a socket just here. So we need to check these. I've already researched the pinouts. So this pin here is the 0 volt section. Pin here is plus 38 volts. So it's getting 37.8. And this pin down here is minus 38 volts. Minus 37.8 pretty much. So that rail was okay as well, that's good. So I'll check that 22 volt rail yet. Right, so the plus and minus 20 volt rails are coming off of J1 on this card here, on the top side, so I've got to sort of reach around and do that. But I need to probe onto 0 volts, which is here for the 20 volt rails. 2 0 volts, one is for this section, and the purple one is for the 20 volt rail. And that's that one there. So I need to probe onto that and probe onto the other side at the same time. So you watch this whilst I do the probing. So I try and get onto the pins. So I've got minus 20 volts here and plus 20 volts here. Yeah, so they're slightly down, sort of 1.5 volts down where they should be. I don't know if that's going to matter. Okay, so those power supplies probably don't matter because they're actually an unregulated supply. So it's purely a rectified supply, comes straight from a transformer. It's rectified, smoothed, and then sent out. There's no regulation on that 20 volt rail. Being 20 odd volts is going to be alright. My line input voltage is about 230 right now. It's set at 240 volt on the input jack on the back. It will be sitting slightly low, so it's probably fine, not worried about that. Well, there's one more power supply we need to check, which I know is already there, but I just want to demonstrate so you know it's here as well. This terminal block just here, very close to one we just used in that socket. So that group there, 4 pins, was actually 3 pins, but 2 of them are the same. That's the 400 volt rails. Right, I don't think it's really regulated. I think it's smooth. We'll power this up. Now there's 2 pins which are the same, but they're both for 0 volts. So that's that pin there and that pin there. I think that's pin 2 and pin 4. So we'll hook on pin 4, and on pin 1 we'll check that one. It's minus 436, and on pin 3 we'll check that one. Plus 438. So yeah, 400 volt rails are present. If you're paying attention as well, you might notice there's a little adjustment just down here, all by itself, which is a bit weird. That's used for the guard adjustment. There's 2 adjustments, one on the power supply and one down here, and you use those 2 adjustments and you get the noise on the guard terminal down as low as you can during the calibration. So that's what that's for, in case you care. So what I've done is some preparation.